This is it, the end of nomenclature. Then we'll move on and talk about moles. Naming acids. I told you that acids have these special, unique rules, and we're going to go through them now. Okay, acids and ionizable hydrogen atoms. Acids are a special class of hydrogen-containing covalent compounds that, when dissolved in water, release one or more hydrogen ions and form an anion, with a -1 charge for each hydrogen ion that was released. So essentially, you lose a hydrogen ion, well, you were electronically neutral. When you lose a positive, what does that mean? You're negative. Okay, if you lose 2 positives, that means you're 2 negative. Ionizable hydrogen atoms is the term for hydrogen atoms that are released in water, are written at the beginning of a formula. Okay, so that's a key there. They're written at the beginning of the formula. Now, there are 2 types of acids, binary acids and oxyacids. We'll go through each. Here's a pair of examples of acids, HCl and H2SO3. HCl is hydrochloric acid, and H2SO3 is sulfurous acid rather than sulfuric. Anyway, we'll see sulfuric in just a little bit. HCl, what that does is it releases 1 hydrogen ion to form a Cl- ion. So this has 1 ionizable hydrogen atom. This is a monoprotic acid. Now H2SO3, what's the difference? Well, it's obviously got sulfur and oxygen compared to the chlorine, but we got 2 hydrogens. So what this is going to do is it's going to release 1 hydrogen ion to form HSO3-. That HSO3- that results is going to release another hydrogen atom, a positively charged hydrogen atom, to form SO3-2-. This is, well, if HCl was a monoprotic, it released 1 hydrogen. H2SO3 would be a diprotic, or more generally, a polyprotic acid. It releases more than 1, or it has more than 1 ionizable hydrogen. Okay, classify each acid as a monoprotic or a polyprotic. And we're just going to say M for mono and P for poly. Okay, A, mono, B, poly, C, mono, D, poly, and E, mono. It's just a question of, do you have 1 hydrogen or do you have several hydrogens that are going to be released, or that are listed at the beginning of your formula. Okay, a binary acid contains hydrogen atoms and atoms of an element from group 16 or 17. I will refer to those generally as group 6 or 7. The number of hydrogen atoms is equal to the number of negative charges on the anion. So you're going to name this with the following pattern. Hydro, then your root word, which we've talked about roots quite a bit now, ic acid. So chlorine, hydrochloric acid. So hydrochlor is going to be our root. Ic acid is the suffix. Okay, how to name binary acids. Hydrogen, your monatomic anion, and hydro root ic acid. Hydrochloric acid. I just did that one. Okay, name these binary acids. We've got that same system. Hydro. Now F is our root. Fluoric acid. Hydro. Furic acid. Then HI, hydroiodic acid. Oxyacids contain hydrogen atoms bonded to oxyanions. We saw some of those oxyanions, for instance, perchlorate. An oxyacid name relates to the oxyanion names as follows. You're going to replace that ate with ic. If there is an ite, you'll replace that with us, and you're going to retain any prefix like per or hypo. So perchloric acid. Well, we take the perchlorate ion to make it perchloric acid. Okay. Now, as an example, well, lo and behold, the perchlorate ion. This would be perchloric acid. Done. So, summary of your acid nomenclature, it's all wrapped up right here. Generally, what we're going to see is ones right here. So, hydrochloric acid, hydrocyanic acid. And the reason that we're kind of living in this area is these are your strongest acids. And that's significant because those strongest acids, they're going to stick with you as you proceed through other chemistry courses. So that's kind of why we hang around with those. At any rate, I hope this has been helpful, and we'll continue on to moles and the mole, or understanding what a mole is, next with chapter 3. All right, thank you very much. Have a good one.